You did it again this morning. You didn't even think about it. You picked up something that was once alive, put it in your mouth, and your body handled it perfectly. But roughly 2 million years ago, the first time a human ancestor did exactly that, everything changed. Not just for that one creature, for the entire future of your species, and possibly for your brain. The story of how humans started eating meat is not a story about hunger. It is not a simple story about survival. It is one of the strangest biological pivots in the history of life on Earth, and its consequences are still running inside your body right now. Before meat, your ancestors ate plants, almost exclusively. Their bodies were built for it. Their guts were long and slow, designed to extract every calorie from fibrous leaves and tough roots. Their brains were small. Their days were spent chewing. Researchers estimate that early hominins like Australopithecus spent up to 6 hours a day just eating, just to get enough calories to stay alive. Think about that. 6 hours, just eating. Then something happened. The planet dried out, forests shrank, the open savanna expanded, and the lush plant food that had sustained your ancestors for millions of years became scarce, unpredictable, and often just gone. This is the moment evolutionary biologist Richard Wrangham calls a turning point in human prehistory. Not a choice, a crisis. And in that crisis, something extraordinary occurred. An ancestor, we are not entirely sure which one, possibly Homo habilis, possibly an even earlier hominin, encountered a dead animal. A carcass. It may have been killed by a big cat and abandoned. It may have died of thirst. What happened next would alter the trajectory of every human who ever lived after that moment. They ate it. Now here is what most people assume happens next. The body rejects it, gets sick, maybe dies, but that is not what the fossil record suggests. The body, even a body that had never processed animal protein at that scale before, had ancient chemical machinery that could handle it, because your ancestors had not always been purely plant eaters. Going back far enough, the primate line was opportunistic. Insects, eggs, small lizards. The enzymes were there. Dormant, underused, but there. What the fossil record does show, however, is that something else happened almost immediately. Something in the biology started to shift. And paleoanthropologist Leslie Aiello and biologist Peter Wheeler documented this in what they called the expensive tissue hypothesis, published in 1995. Their argument was precise and astonishing. The gut shrank. Not all at once, over generations. But as meat entered the diet in greater quantities, the long, metabolically expensive digestive tract, the one built to process raw plants, began to reduce in size. And the energy saved by running a smaller gut got rerouted. It went somewhere else. It went up to the brain. Your brain is the most expensive organ in your body. It uses roughly 20% of all the calories you consume, despite being only about 2% of your body weight. For millions of years, your ancestors could not afford to grow it much bigger. The gut was taking too much. But when meat, dense, calorie-rich, protein-packed, entered the diet, the energy equation changed. The gut could afford to shrink, and the brain could afford to grow. Homo erectus, the first hominin to look genuinely human in body proportion, appeared around 1.9 million years ago. They had a brain significantly larger than their predecessors. They also had clear evidence of meat eating in the archaeological record, cut marks on animal bones, stone tools built for butchering. The timing is not a coincidence, but here is the part that never makes it into the textbook version of this story. The first time meat entered the diet at scale, it was not cooked. There was no fire. Fire comes later, much later. What your earliest meat-eating ancestors consumed was raw, cold, often partially decomposed flesh torn from a carcass that someone or something else had already opened up. What did that do to the body? The stomach, it turns out, is extraordinarily acidic. Human stomach acid is among the most acidic of any primate, comparable in pH to vultures and other dedicated scavengers. Gastroenterologist Michael Rosenblum has noted this striking feature of human digestion. We are built more like scavengers than our closest primate relatives. Chimpanzees have considerably less acidic stomachs than we do. The hypothesis is that as our ancestors ate more meat, especially raw or old meat, the ones who survived were the ones whose stomachs were most hostile to the bacteria that comes with it. The acidic stomach was selected for. The ones with weaker stomach acid got sick. The ones with stronger acid lived, reproduced, and passed the trait on.